will talk about C implementation of matrix multiplication. Before we talk about actual implementation, let's understand the basic definition of matrix multiplication. So let's consider this example. Here I have taken two matrices, matrix A and matrix B. Both are of size 3 cross 3. So ultimately 3 rows and 3 columns, and elements are 1 to 9 for matrix A, and matrix B also contains same elements but in reverse order. So the main idea is we want to multiply matrix A with matrix B, and ultimately the final answer will be stored in another matrix, let's say matrix C. So the core idea of matrix multiplication is row elements of the first matrix will be multiplied with column elements of the second matrix, and ultimately we will get the final answer. So let's try to understand. Let's talk about the very first entry of this final matrix, let's say C matrix. So let's see how this 30 comes. So first we will multiply 1 with 9, and then 2 with 6, and 3 with 3, and then we will add this multiplications and we will get this particular answer. So ultimately we are multiplying first row of this particular matrix, matrix A, with first column of matrix B, so that we can get this particular element. Similarly, we'll multiply first row of matrix A with second column of matrix B, and we will get the second entry, and so let's consider another example. So instead of 3 cross 3, let's say we have 4 cross 4 matrix. So A is of size 4 cross 4 and B is of size 3 cross 3. So in that particular case, in the first row we will have one more element, let's say 10 here just after 3, and now let's try to multiply A with B. So imagine that now A is not this, but it's a new matrix of size 4 cross 4. So in this particular case, 10 must be multiplied with this particular first element of the fourth row of B, but since B is of size 3 cross 3, there is no matching element corresponding to this 10. So what we can say, matrix multiplication is not defined. So what the underlying condition for valid matrix multiplication is, we can say that number of columns of first matrix must be equal to number of rows of second matrix. So here both the matrices are of size 3 cross 3. So we can say that matrix multiplication is well defined for this particular case. But if we consider this particular case where A is of size 4 cross 4 and B is of size 3 cross 3, in that particular case matrix multiplication is not defined. So in general, matrix A must be of size n cross p and matrix B must be of size p cross q. In that particular case only matrix multiplication is well defined. Now let's talk about implementation, but before we go to the implementation part, let's understand the basic idea. So before we actually do this work, we must have entries for A as well as B. So in order to get that, we require two variables. Let's say variable I is corresponding to rows, so I will go from 0 to 2 in this particular case, and similarly we will have one more variable, let's say J, and J will go from 0 to 2 in this particular case. This is corresponding to 3 cross 3 matrix, right? So therefore anyway we require two for loops in order to just get elements of each individual matrix.